Hi, welcome back. I'm going to start a two-part series only because I don't like my videos typically to be longer than 5 minutes, but I really wanted to focus on a standard in fourth grade that I've known teachers to get kind of frazzled with, and that is the standard that talks about representing fraction a over b as a sum of fractions 1 over b, where a and b are whole numbers and b is greater than 0 and blah, blah, blah. So I think teachers get a little bamboozled because they feel as if the whole use of variables A and B is a little overwhelming. Like, what is this standard really asking students to do? So in layman's terms, what the standard 4.3a is talking about is that students simply have to be able to represent a fraction. Okay, and that fraction has to have whole numbers, so it can be just a regular fraction. We'll say 4/6. And um, A, which is the numerator, has to be, or can be rather, greater than B, which means we could be making an improper fraction, or and I really should say and, because this is a two-part standard. It says that b, which is the denominator, has to be greater than 0. So in other words, b has to be a positive number. A can be less than b, but a can also be greater than b. In other words, you can use proper or improper fractions. That's the layman's terms of it. So you could do this, start this activity rather by asking students to take a sheet of paper, fold it into 6 parts, and then ask them, once they have it folded, what would one of these parts represent? What fraction would one of those parts represent? And students should understand, and if not, we'll guide them to that understanding, but that one part of the fraction is 1/6. And that's why it says should be represented as a sum of fractions 1 over b. In other words, they should be able to use unit fractions to label each of their parts. Now, let's backtrack and say that you ask the students to then shade in, we'll say 5 of those pieces that they have folded. Then you may say, okay, I want you to represent this fraction using those unit fractions. And let's make a number sentence out of it. So they may say 1/6 plus 1/6, and we could guide them to this understanding, plus 1/6 plus 1/6 is equal to 5/6. Okay, and actually I just realized I wrote 4/6 here, so let's change that for the sake of being accurate to 5/6. That's the extent of that standard. Now, again, the standard does include proper and improper fractions, so let's just look at an example of an improper fraction. Let's move to this model here. Let's say in another activity, a follow-up activity, you gave students just some fraction towers or some fraction tiles or simply some fraction pieces like the circular models here. And let's just say you distributed 7 of these circular thirds to each pair of students or each group of students. You may tell them that the fraction is written 7/3, or you may ask them, how could we write this fraction as a numerical fraction? Or you could just possibly build to that. And so I would think in order to build to that, maybe help the students by asking them or guiding them to say, how many pieces do I need to put together in order to make a whole lot of these pieces? And let them just kind of discover, they're fourth graders, so they should come to it pretty quickly, that 3 of those pieces would make a whole. But the ideal here is to get students to really represent, and so I might have them draw around 3 pieces so that they could label that as one whole, and then ask them, can I pull another whole out of these this bag of fractions that I've given you? And they should be able to determine that I have enough for a second whole. And eventually we want them to build to the point where they can say that this fraction 7/3 can also be written as 2 1/3. Now understand that students don't have to know the terms improper and mixed number. We want to say greater fractions greater than a whole, but they are allowed to use those terms. They're just not necessarily held responsible for them. But here's the greatest thing about this. If students are able to circle those pieces that represent a whole, then when you take away the concrete models, and the standard does not have to be taught using concrete models, I just think it's great for building the success of the students, and now they're just looking at a straight number sentence, then look, the strategy is still there. So if you were to write this number students, or students were to copy that number sentence down, they would still have that strategy of knowing that I can circle 3 of those thirds to equal one whole, and I can see how many wholes I can get out of that number sentence. Now, working backwards, let's say you gave them the fraction 3 1/4. I would encourage students to draw a representational model. So here they need to see that I need to draw 3 holes, and they would draw 3 whole pictures, and then I need to separate each hole into 4 parts. Okay, and then maybe have them stop and talk about, now how many pieces do I have now that I've drawn a picture of 3 holes and each are separated into 4 parts. I have 12 parts. Okay, now it says I also need 1 more fourth, so I'm going to take my last piece and break it into fourths, but I don't need all of my fourths from that extra. I just need one of my fourths. So altogether, then I have a total of 13 of these fourths. And see, now we don't really need the tricks of doing the backflip and dividing the numerator into the denominator, multiplying the whole number by the denominator, adding the new, all of those things, those algorithms that we teach students before we really help them understand the concrete basis of the standard. So stay tuned for part 2 of this standard. Thank you.